Hi guys. So in this video, we will be discussing about how HashSet HashMap works internally and how can you implement your own custom HashSet as well as HashMap. Okay. So I will be combining both these topics together in this video because HashSet internally implements HashMap only. So it's like waste of time to create two separate videos for you. So I will customize it all in both of the topics in this video only. So without any delay, let's get started. HashSet internally implements HashMap. But the question will arise in your mind like why HashMap is not a part of collection interface? Because HashSet is internally using HashMap, so HashMap should be as a part of collection interface, right? But why it is not there? So let's understand. Set is what? Set is a part of collection interface which basically doesn't allow duplicates. Okay, so whatever data you are adding into set, it will not allow duplicate. But the main thing is how it is working internally. Like we are adding elements into array list, it is allowing duplicates, but while adding elements into set, it is not allowing duplicates. So how it is working like that? So it's very much simple. So set internally implements map, and map has a unique key. Okay, so keys will not be duplicating in case of map. So set, when you are calling add method, so there are multiple methods present within set. Okay, so set will have like add method. Okay, it will have remove method. Okay, so my handwriting is not that good in this, so bear with me. I hope you are getting the concept of it. Then contains method. Okay, so these are mainly three methods that we most commonly use, and there are other methods also, like size method is there. Okay, where we are checking the size of the set. Okay, then is empty. There are multiple methods, like there are n number of methods presented in set interface. So basically hash set, which is internally implements this set interface, will contain these methods. Okay, implementation of these methods. So basically these are the basic methods that are most commonly used in our day-to-day project works. Okay, so we need to understand it very deeply, like how these methods are internally working. Okay, so first of all we'll come with set. Okay, so we'll be first understanding like how add method is working in this set. Okay, whenever we are adding any elements into the set, then what is happening internally, guys? It is internally calling put method of map. Okay, so internally whenever we are adding any element into the set, it is maintaining uniqueness. Okay, so let's suppose I am adding set dot add. Let's suppose I'm adding some string values. Okay, so it can be any string, it can be like a I'm adding. Okay, so what is happening internally? It is going inside for a map. Okay, and map is containing what? Map is having data. Okay, basically what data, what value it is coming from here. Then it will be having the next node's address. Okay, it will have hash code also. It will contain hash code of that particular element which you are adding in it, like the key part, and the next node address will be storing over here. Okay, so basically these three things will be stored inside a particular node. Okay, so whenever we are considering map, how data is getting stored inside a map, it is getting stored in the form of a node. Okay, so one node will contain data. Okay, then it will contain hash code and it will contain next node's address. These three things basically it will be containing. Okay, so like that, and one node will not be happening, right? So it can have a lot of nodes, so all nodes will be connected via linked list. So in the previous session we have already understood like how can we implement our own custom linked list. So if you haven't gone through the video, so you can go ahead in the card section. Okay, so yeah, so if you have gone through the linked list and you understand the linked list concept, because that is very much essential to understand the map concept over here, because internally map is making use of linked list only to store the elements. Okay, so first of all we'll be creating one normal node containing data, hash code, and next node's address. So initially for a particular bucket it will be null only, and then as soon as I'm adding one more node, so it will be getting connected in the form of linked list, because linked list is not index based. Okay, so it is like storing data into space where each and every element is getting identified through their address or memory location. So like that data is getting stored. So whenever I'm adding any element into the set, so internally it is being stored as a key of the hash map. Okay, so let's suppose I'm adding a over here. So what is happening internally? There will be two things, right? Key and value of a hash map. Okay, so key will be what? Key will be whatever you are passing there in a set. Okay, so that will be passed here in the key part. Okay, and value will be some dummy value. It can be object type. Okay, it can be like any object type. So it can be any dummy value. You can assume any value of your own. It doesn't matter because key should be unique and value can be duplicate. Okay, value can be overridden. So same key can have a different value. So every time when you are adding value for a same key, then what will happen? It will override the existing value of the map which is attached to that particular key. Okay, so in a map, if you will observe, there will be like key value pair, right? So for a particular key, you can have n number of values. So whatever will be the latest value, it will override the pre-existing value for that key. But we can't add another record in a map with the same key. So that is not allowed basically because map maintains uniqueness. So how it maintains uniqueness? Through this key only. Key should be unique. So that's why set maintains uniqueness. So whenever you are adding any element into the set, it is going inside the key and key is immutable, key is unique. Okay, so that's why whenever we are adding duplicate elements into the set, it is not being added. So that's why we are maintaining like set containing only unique set of elements because of this key part of the hash map. And value can be any value, so it doesn't care. Okay, so it doesn't matter anymore. So like that, add method is being worked upon in the set interface. And for remove, what will happen? We are passing like which element you want to get it removed from your hash map. Okay, because set internally using hash map only. So once you remove the element, it will go inside the map. Okay, and it will check whether that element or the key part is present inside that or not. Because whenever you are adding any element into the set, it is going for a key, right? So whenever it will try to remove the element, it will check for that particular element in the existing map's key part. Okay, so if it is not there, then it will return me like data is not present. Okay, you can write that logic. It will not return you anything. Okay, or else if data is present as a key of the hash map, then what will happen? It will remove that data from the map. So like that, remove method will work. Okay, then there is contains method. So contains method will do what? Here you will pass the element like set dot contains. So basically contains method you are using for search operation. So if you see the linked list video which I have created in the last video, so there I have talked about contains method also. So basically contains method is nothing, it's a search operation. You are searching for a particular element inside your entire list or map or set or anything. Okay, so each and every collection interface has this method. Okay, contains method. Add, remove, contains, these are common methods across all your interfaces. Okay, so contains method is nothing but it will search for that element which you are trying to do operation on. So basically it will return me boolean value. So it will tell you like whether that element is present or not. Okay, so if that element is present, then you can do any operation for that particular element. Like you can either remove from that map or you can add it as a new node or you can do any operation that you are thinking of. Okay, so that will come with contains method. And with size, you can check the size of your hash set. So what is the current size of your hash set, that you can get to know with this size methods. So these are the basic methods which you need to use for implementing set. Okay, and in set there are various categorization of set like hash set, then there is linked hash set, then there is like tree set. Okay, there are like multiple categorization of set, and basically we are making use of hash set, linked hash set, and tree set only in our projects. Okay, so these three things should be very much clear about. Okay, so I've already created video separately on this kind of segregation part, like what is the major differences between this hash set, hash map, linked hash map. Okay, so linked hash map or linked hash set we have to make use of when we have to maintain the insertion order. Okay, because normal hash set or hash map doesn't maintain the insertion order. Okay, it will maintain the uniqueness, but it will not maintain the insertion order. For that, we need to make use of the advanced version of hash set, that is the linked hash set. Okay, and tree set we have to make use of when you have to make the data comparable. Okay, if you want to add data in a sorted fashion, then you have to go ahead with tree set or tree map. So this is the basic diversification of entire collection interface set and map part I wanted to talk about. So this is the thing that is very much crucial for interview perspective as well. Okay, so now this is the part for set, like what are the internal implementations of set methods. Okay, and how set works internally. Okay, so I have talked about this in this. So now let's understand something about map and then we can go ahead in the code to understand like how these two classes will be utilized to implement our own custom methods of this hash set and hash map. Okay, so first of all, let's understand like how hash map works in it. So now, by now you got to know like what is map. It is a data structure basically which is not coming as a part of collection interface, but it is a part of collection framework basically. So why this map is not being kept as a part of collection interface? Because the storage process or fetching operation is entirely different as compared to other interfaces present in collection interface. So if you see like list, queue, set, these all follow similar technique to insert the data into that particular data structure. Okay, so list will have like add method, it will have remove method, and it will have like one data that you can add it. There is no diversification in the form of key value pair. Okay, so storage process remains the same for list, queue, set. Okay, but when you are coming for map, just to store the data into the map, there is a different process altogether. Okay, it is not following what list, array list, linked list is being followed upon. Okay, so internally it is having key value pair. Okay, whatever data we are storing in the form of key value pair. So entire set of operations will differ because of this operation. Okay, the process will vary. Okay, so we have to check for key to see the value. Okay, key should not be duplicate. Okay, it should be unique and immutable. So these are some of the properties that we should know for map, and because of this property of key value pair, it is being kept different from collection interface. I hope you got a clarity on this, like why it is being kept different. So now let's understand like what are the internal implementation of the hash map and what are the methods present within the hash map which are most commonly used. Okay, so to understand the internal implementation of map, first of all, let's understand like how data is getting stored inside the map. Okay, so we all know like map is having how many buckets. So each and every node which you are seeing over here, it is basically called as buckets. Okay, so if you see, it will be like starting from 0, then 1, then it will keep on going till 15. Okay, because you all know like hash map has a size of 16. Okay, starting from 0 to 15. So this is basically the structure of the hash map, and set also stores data here only. Okay, because set internal implements hash map. But before coming here, there is one black box structure that we have to understand. So what will happen? Let's suppose we are adding some data to set, or we are adding some data to map. Okay, so what will happen? So first understand put method. Put method is very important in map. Okay, so this is basically one of the methods present within map interface, with the help of which basically you are inserting data into the map. Okay, so put method takes two things. First, it will take key, and then it will take the value part. Okay, so what will happen over here? You will get your key part. Okay, and then corresponding to that, you will get your value. So for that particular key, what will happen? It will go through the hashing mechanism. Okay, so there is something called as hashing mechanism, where it will calculate the hash code of it. So there is a different process altogether to calculate the hashing mechanism. It's like 2 to the power 31. Okay, plus the existing value of it. Okay, so this is a process. Okay, it will go through the loop and it will check for all the keys, and then it will calculate 2 to the power 31 plus there will be some value will be there, like result. It's considered as a integer value. Okay, result will be considered as 1. So 2 to the power 31 into result plus the value. Okay, so like that, some calculation is there internally with the help of which this hashing mechanism is working. And then after calculation of this hash code, basically, so you will get 16-bit integer. Okay, you will get 16-bit integer. So it can be like 0, 1, 1, 0, 1, 0, like binary format. You will get 16-bit integer. Okay, and then this data that you will get for your key, it should get stored in the particular hash map. But the major question which arises over here to understand is like this is 16-bit. Okay, but the size here given in for hash map is lying between 0 to 15. So how can we store this 16-bit integer within this range of the hash map 0 to 15? It will not fit into this hash map, right? It will go outside the range. So to resolve this issue, what will happen? Basically, we have to calculate the hash code of it first, and then we have to do modulus with the size of the hash map. So what is the size of the hash map? It is 16. Okay, so you already know this mathematics, right? It's a basic form of maths. Like whatever value you are getting, if you are doing modulus with that particular element or value which you are doing modulus with, then whatever value will come, it will be lesser than that particular value which you are doing modulus with. This is the basic maths, and that is why I love maths. There are a lot of facts about maths that you will love to know about, that I will create a separate video upon. So this video is dedicated for the internal implementation basically. So I wanted to tell you, like whenever you are doing modulus with the size of the hash map, whatever value will come, that will come in the range of 0 to 15. Okay, which we want basically. That's why we are doing modulus operator. Okay. So like that, it is working. So once you get 16-bit integer and you are modulus with the size of the hash map, you will get some index value. So let's suppose you are getting index value as 1. Okay, let's suppose you got 1. So what will happen? Whatever key value pair it is coming ahead with, it will slowly go ahead. Okay, whatever key value pair is being calculated over here. Okay, so that key, it will go to the specified index. So let's suppose the index value is 1. So it will come over here, and that key value pair will be stored over here in the form of node. Okay, so node value it will be storing. It will store key. Okay, then it will store hash code, then it will store value, and then it will store next node address. So these 4 data will be storing inside this node basically. Okay, so it will be storing what? It will be storing key which is being passed. It will be storing hash code of that key. Then it will be storing value, because we are passing value also, and then it will store next node's address. So for set basically you are not passing value, right? So it will store dummy object over here. Some dummy value it will be storing over here. Okay, and then it will be creating a normal one single node, and currently next will be pointing to null because there is no other node as of now. Okay, but what will happen? Let's suppose some other key came. Okay, so there can be like other key which has the same hash code. That also can be possibility, right? So some other key can also have the same hash code. So if hash code is same, then we are modulus with 16. So same index value will be coming. So if that is the case, what will happen? It will again append this node. Okay, whatever new node is being created for this key, like it is key 1 and key 2, for this key, what it will do? It will create a new node altogether, and it will store data here as key 2. Okay, key 2, then hash code, then value, and then next node address. Like that data will be stored, and this next node will be storing as null over here. Okay, so like that data will be keep on getting stored. So there can be a scenario where all keys can have same hash code, then all data will be stored in this. But there is a limit to that. Okay, you can't store all in the same index, otherwise efficiency will be reduced, time complexity will be increased. Okay, so to resolve that problem, there is something called as resizing concept. Okay, there is something called as load factor. So each and every interfaces or the categorization which we have discussed, like list, set, and map, all are having certain load factor. Every people in this world has some efficiency, right? They can't work very much more than their efficiency. So it will impact their productivity. The same thing happens with here as well. So whenever you are adding data which is crossing the threshold value or the load factor value, it will start reducing its performance. Okay, performance value will get reduced. So that should not happen. So for that, there is something called as load factor. Okay, so load factor is being calculated like whenever it reaches 75% of this entire hash map, it will resize. Okay, so basically it will double its size. So let's suppose it is 15. Okay, 0 to 15, like 16 is the size of the hash map currently, right? So what will be the load factor? I will calculate like 75% of 16. So whatever value will be coming over here, so that will be my output. Okay, so let's suppose 75% of 16 is like 8. Okay, let's suppose 8 is coming. So as soon as you are adding elements into this hash map, right? So as soon as it reaches 8, then what will happen? It will double its size. Okay, so it will get the alert message. Like map will also have the alert notification. Okay, so as soon as it reaches 8, it will get the notification like it is crossing the threshold. It is crossing the threshold. Okay, it will double its size. So now it will be resized to 30. Okay, so now the size of the hash map is 30, and now hash code will calculate differently, because modulus previously was with size of the hash map, right? Because previously size was 16. So we have calculated accordingly. So once it got resized to 30, then what will happen? This 16 will be removed and it will become 30 now. Okay, so now has this index value will change. So let's suppose for the same key, I am getting the same hash code, but modulus value got changed. So index value may get changed. So let's suppose it now came as 4 for the same key. Okay, now the index value is coming as 4. So now that particular node which was appended over here, it will be removed from this particular node, and this will go to fourth node, and it will be added over here as a node. Okay, I hope you got the clarity. So in that, it will resolve two problems. First, it will not increase, the capacity will not increase against the load factor. What is the maximum capacity of that map? That problem is resolved. And second problem that I will be talking about is rehashing concept. Okay, so main thing is like whenever we are adding any elements into the node, there is a limit to that, right? So there is a threshold to that. You can't keep on adding node to that particular index value. So let's suppose there is a threshold of 8. Okay, you can't add more than 8 elements into that one particular index. So but if you are keep on adding, so it will reduce the performance of this map. So to resolve that problem, basically what is happening over here, it comes the concept of rehashing. Okay, so what will happen over here, it will go till the size of 8. Okay, so it will be working in the form of linked list till it reaches to the size of 8. Like node creation will happen till it reaches 8 nodes. Once it crosses the threshold, like 8 is being kept as a threshold. Okay, once it crosses the threshold, it will now behave like a red black tree. Okay, it will be working like a red black tree now. So whatever nodes we are passing over here, it will be passed on to this red black tree. Okay, and previously what was the time complexity? A time complexity was O of 1. Okay, generally time complexity of hash map is O of 1, because whatever elements you will get you can directly get it via the key value pair. Okay, so that's why you're not iterating through the entire set of map basically. Okay, so that's why the time complexity is O of 1. But there can be worst case scenario. When can be the worst case scenario? When you are getting the element which is present at the end of the linked list. Okay, because it will keep on getting added in the form of linked list, right? So let's suppose you want to fetch the key which is there at the last node of the linked list. Then tell me, you have to iterate till the last, right? So in that scenario, time complexity becomes O of n. Okay, and to resolve that problem, basically from Java 8, this concept came into picture. Whenever it crosses the threshold value, it will convert to red black tree, and in that scenario, time complexity becomes what? O of log n. Okay, so there is also a different story, like why for red black tree time complexity becomes O of log n, because it's a tree structure, and each and every level there is like 2 to the power happening, like first level 2 to the power 0, second level 2 to the power 1, third level 2 to the power 2, then till nth level it will be 2 to the power n. Okay, 2 to the power n equal to k, and if you take log both side, it will be coming as log of n. If you take log to the base n to both side, if you are doing this log both side, then the value you will get for n will be around log n basically. Okay, the value will get it as log of n. Okay, so this particular time complexity is like a drastic reduction of time complexity from n to log of n. Okay, so if you see the graph of logarithmic time complexity, it is like very much optimized as compared to the linear time complexity wala graph. Okay, so once you see the graph of two time complexities like O of n and O of log n, you will get the idea what I'm talking about. Okay, so this is a thing that I wanted to tell you. So I hope you got the clarity like how this put method is being working over here. So first of all, this resizing concept, rehashing concept. Okay, then when it reaches to a particular threshold, then changing to red black tree, and then if it is less than a threshold, then it will again become linked list only. Okay, so these are the certain things that is very much crucial to understand for you from interview perspective, as well as to learn it like how it is working internally. And key part, whatever value you are adding in the key, it can be employee, it can be student, it can be string. So basically whatever value you are passing in the key part, it should be immutable. Okay, that should be unique. Okay, so this thing you should be taking care about whenever you are implementing map. Okay, in the projects I'm talking about. So this was it for put method. Okay, next method is get method. So when you understand get method, what is happening in this get method, basically you are passing the key over here. Okay, and for that particular key, I want to get the value of it. How will you get the value for that particular key? So all the data which is being stored over here in the map, it is being stored in the form of nodes, which contains node data like key, value, hash code, next node's address. These data will be stored. And whenever you're trying to get something, you will try to iterate it over the entire set of linked list. Okay, so there can be a chance like get of that key, and that key is present at the end of the linked list. Again, time complexity becomes O of n. The same story will be there. Okay, but get method operation is to fetch the data from the map, and put is store the data into the map. The same. Okay, put means putting something, get means getting something. That is a simple thing I wanted to tell you. Then contains method is there, which is same as set. Okay, size method is same as set. Okay, so the rest of the thing remains the same. This put and get method, there is a difference for set. And set internally implements map only, but value is dummy object for set, and for map you are actually putting the value for that key. Okay, so this is the difference between set and map. It's a slight difference. And this was it for the understanding of how internally it is set and map being implemented. Okay, now let's go on to the code and see like how we can implement this set and map method. I hope you can see my screen now. So if you see over here, I've created one custom hash set. Okay, so this is not a hash set which is there in collection interface, okay, which is created by Java people. This is our created hash set which we have created. Okay, I'm adding set.add apple banana. I'm adding some string values and checking the size and checking whether banana is present in this set or not. Okay, by checking content. So context method, I already told you, it will return me true or false boolean value. So then it will remove banana. And then after removing, I'm checking whether it's removed or not from the set, and checking the size and printing the elements. This thing only I'm doing, the basic operation of set. Okay, so let's run it once to see like if it is working similar to actual set. Yeah, to see, if you see over here, it is showing original size as 3. Okay, because there were 3 elements into this set. Then contains banana initially. Yes, it contains banana. Then after removal, you are removing banana from the set. After removing it, it is returning me like it is not containing banana. Okay, then size becomes 2. And now what are the elements? Orange and apple. Banana got removed. Okay, so this is working perfectly fine, similar to our actual hash set implementation. Okay, but let's understand like how it is working like that, how I have created like this. So for that, let's go to hash set, and then I will go to hash map, because hash set internally implements hash map only. So if you don't know hash map, you can't understand hash set. Okay, so before learning hash set, try to understand hash map. Okay, but basic thing you should know, like hash set doesn't allow duplicates. Internally, it is calling map method. So these things should be known to you before. Then you move ahead and understand map first. So I've already told you like how internally it is being implemented. Let's understand through code perspective as well. Okay. So this is custom hash set, passing some generic value. Okay, it can be any generic which you wanted to pass over here. It implements iterable type. Okay, so iterable is nothing, it's an interface basically. Okay, so it is basically used for iteration. So there are multiple methods present within this iterable interface, which we generally need it over here to override the values, override the methods. Okay, then some dummy values are passed over here. I've already told you it can be like any object type which you can pass as a value for that particular set key. So set.add, that is what? That is a key only, right? And the value we don't know, that is a dummy value. So for that sake, we have created dummy value to show you. Then custom hash map is being created because internally it is being making use of hash map only. Okay. Then what is happening here, the basic operation I've shown you, the internal implementation is there in hash map only. Okay. So we have created constructor. Within the constructor, it is map object it is created. Okay. So it is actually set, but internally, whenever you are creating constructor of set, you are actually creating constructor of map. Okay. So that is the magic happening within it. Okay. And then there's add method. You are adding element. So internally, it is putting the element into the map with key value as the element being passed over here, and the value is some dummy value. Okay, and just checking if it is equal to null, then it will return me null, or else it will return the actual value. Okay, so it will put the value into the hash map. Then it will check the contains, whether the data is contained in that or not. Contains key. Okay, then because value you are passing here into the set, that is going ahead as a key of the hash map. Okay, then remove, you are removing the element from the map. Okay, you can see, right, internally everything is map. You are just looking from top view that you are seeing set, but actually internally 99% is map only. Okay, then clear, you are clearing it just like you are clearing map. Okay, you are checking the map size is empty, checking the size of the map. Iterator, you are iterating to the key iterator of map. So these internally, if you see, all the methods which you can see inside is of map methods only. Okay, so it's like set, but internally it's using map. So now let's understand like how we can implement hash map methods. Okay, so we didn't implemented anything specific for hash set because hash set has its no unique implementation. Okay, it is dependent on hash map only. So if there is no hash map, there is no hash set. It's as simple as that. So now let's understand hash set methods. Okay, so if you see over here, I've created one class, node class containing key value, because here data is getting stored in a different fashion, right? If you have seen my earlier videos of array list, linked list, we didn't created anything like this, like key value pair. This has been created only for hash map. That's why map is being created separately. Okay, it is having key. Previously for array list it was data, okay, and node, but now it is key value. Okay, so data is being stored as a key value pair. I hope you got this, like why we have created this type. Then custom hash map, we are passing key value. Okay, then we are passing initial capacity. So initial capacity is 16, we already know. Okay, and load factor is 75%. As soon as 75% of the map is filled, it will double its size. Okay, then we are creating linked list node buckets. We already told you, right? Whatever data is being stored it's stored in the buckets only. Okay, so each and every bucket is filled depends upon the key hash code. Whatever hash code is coming, depending upon that, data will be stored in the bucket. Okay, then this is the constructor of custom hash map. We are adding data in the form of linked list. So initially, whenever you are calling constructor of map, it will create linked list internally with a default initial capacity. So initial capacity is initially 16 only, so it will create a linked list with size 16. Okay, so initially size will be 0. Okay, because no data is being added still. Then put method is being called, where return type is of value type. Okay, we are passing key value pair over here. We are calculating index. Okay, so first of all, before putting, we have to check whether that value is already present or not. So first get the index of it. So getting index is very much simple, right? What we are passing over here, we are checking whether key is null or not. If it is null, it will be 0, or else it will calculate a hash code of that key. So similarly, like whenever you are putting element into the hash map, I already told you hash code is being calculated, and hash code is of 16-bit size, so it will not be fit into the hash map. So we have to do modulus with the size of the hash map. So size of the hash map is like 16, so we can do modulus, we can get the actual index location, and we can point it to that particular location. Okay, so let's go back now. So here we got the index. Okay, if the bucket at that particular index, okay, basically the value at that particular index, if it is null, it will create a new linked list. Okay, because you are adding new element, right? And initially there were no nodes present over there, so it will create a new linked list basically. Okay, or else if data is not null, it will do the iteration for each value of that particular index. Okay, and then it will check whether the value is already present or not. Okay, so key, it will check nodes key and this key. If it is matching, then it will do the overwriting basically. So here basically it is doing the swapping. Okay, so whatever value is being coming over here, the key part, if it is already there into the hash map for that bucket, it will overwrite the existing value of that key, and then it will print the newer value, which is the new value which has just been added. Okay, so that this property I've already told you. Then if it is not that case, then what will happen? For that particular index, it will add the new node with key value pair. So similarly, it will be adding as a new node in the linked list, and then size will increase. Why? Because new node has been added to that linked list, right? So that means new node means new element, means new size is increased over here. And we have to keep on checking also whether the size which is getting increased, it is crossing the threshold or not. We have to check that also. If it is crossing threshold, it will double its size, right? So it will check with a load factor. It should not be more than 75%. So it will keep, size will keep on getting added. Size plus plus will keep on happening till it increases with the load factor, till it reaches the load factor. Once it crosses 75%, then what will happen? It will call a resize method. It will double its size. So if you see the resize method, what is happening? I'm creating one linked list node with old buckets, and then I'm creating new linked list with double its size, and then I'm iterating it, and then I'm putting value over here. So basically you are copying the existing map data to the new map with double size. Okay, so you can imagine like there are 5 nodes in a map with 15 size, and there is another map created with 30 size, and those 4 nodes will be copied to the new map. But the index value may get changed. Okay, because modulus will value will get changed. Now you are not doing modulus with 16. Now you will do modulus with 32. Okay, and doing anything with modulus with any new number, it may give you some other value. So index value, there is high chance that it will not remain the same. So this way you are removing one more problem. Okay, so like the rehashing concept is there, right? So it will not allow to reach the threshold of 8, after which it will get converted to red black tree, right? So that problem will not be there. That hash collision will not be happening again and again, again and again. It is appending to the existing nodes in the linked list. So those problem will not be occurring for you. Okay, so this is the thing, like how resizing is happening. This is very important concept. So whenever it crosses the load factor of 75%, it will double its size. Okay, yeah. So this is a thing for put method. I hope you got the clarity of put method. Okay, if there is any doubt, you can put it in the comment box, or you can ping me on LinkedIn as well. I can help you there as well. Okay, then there is a get method. Okay, so if you see, put method also have a return type of value type. Okay, and get method also have a return type of value. So basically value is more important. We are passing key. So here also you are passing key and value. Okay, so in get, what is happening, you are passing key, and based upon that key we will be getting the value. Okay, so for each key there is a value associated with it, so I need that. Okay, so I will first calculate the index to check whether data is already present or not. So if it is present, we will get the index, and then we will get the value for that particular index. Okay, so bucket is what? Bucket is the linked list. Basically we will be having key value pair, where basically the node data corresponding to that index we will be getting, to check whether the data is already present or not in the linked list. Okay, so if bucket is null, then it will return me null. That means no data is present. If a node corresponding to that key is present into that linked list or at that particular index, then we will be iterating, we'll be checking, and we will be returning the node value. So there can be a chance, right? Like node key and the past parameter key gets matched. That means key is there in that. Okay, so you will be returning the value part of that map. It's very simple. Okay, so you are creating linked list with that node. You are checking whether the bucket value is present or not. Basically the linked list value is present or not. If it is present, it will return me the value of it, or else it will return me null. It's as simple as that. Okay, so once you understand the code, you will try to write it down by yourself. You will get more clarity on this. Okay, so main thing is, try to do it by yourself first. You got the clarity, you got the flow, you got the knowledge. Try to do it by yourself. Then you see like where you lacked. Then you again try to correlate, and then again write. Like that only you will learn. Okay, then contains key. So basically you're passing key over here and checking whether the key is present or not. Okay, so it will call get method only. So get method is the same thing which I have already told you just now. Okay, so this is not a new thing basically. So contains key, I hope it is very much simple to understand. Then remove. So remove is again very important operation, similar to get operation. Okay, so remove, what is happening, you are removing the particular key from the map. Okay, so there are a lot of things that we have to see. First of all, we have to see whether index is present or not. Okay, we have to see whether that node is existing in that particular bucket or not. Okay, so if it is existing, it will create a linked list out of it. Okay, if bucket is null, that means there is no linked list available for that particular key. Okay, if it is available, we'll be iterating it. So there is a iterator method. Okay, you remember we have implemented iterator for the class. Okay, so it has internally iterator method. Okay, and then with that iterator, we will be iterating through the entire set of map while iterator.has next. So has next is nothing but it's a boolean value. It will give you a suggestion that whether the next value is present or not, whether the next node in the iterator process it's present or not. So if it is present, it will go ahead, it will create a node, and then it will move ahead. So it will fetch the existing the next node data. Okay, in the iterator.next. And then it will check the key part. It will compare the key part. If this node's key is exactly equal to the key which is passed here as a parameter, then what will happen? It will remove that particular key value pair from the map, and size will be reduced by 1. Okay, and then we are returning the node value. So basically we will be returning here what value is being removed from the hash map. So that information it will remove from here. So once you call the remove method, you will get the idea like which particular value is being removed from the map. So like that it will happen. So this particular part is very much important. Okay, so first what we are doing, we are iterating through the map, checking whether data is present, next that node is present or not. If it is present, we are creating node, checking the key part. If key part is matching over here with the parameter passed, it will remove. That means we don't want that key value pair. So we will be basically removing that. So like that, remove method will work internally. Okay. Clear method, you are clearing it. Basically size is getting 0. Okay. Default capacity to 0. Then size, it will return with a size. Then key iterator. So basically there is a key iterator method also present in map, right? So basically it will iterate through the key. So it will return me the iterator basically. Okay. So iterator, I have already told you, like it's an interface. It has some internal methods implemented like has next method. So here basically it will override these methods and it will check whether these elements are present or not. Okay. So if bucket iterator dot has next means next element is present in a bucket and its index is less than the bucket's length, then what will happen? It will go inside and will iterate through the entire bucket index. Okay. Whatever value it's been passed over here, it will be iterating through that particular bucket. Okay. And then it will store the data into bucket iterator and then it will keep on giving you the next value. Okay. So like that it will happen. And in next, it will give you the exact value. In has next, in iterator, it will just iterate and tell you whether if there is any element present or not in the next position. But in next method, it will give you the actual key for that particular bucket. Okay, so this is the difference between has next and next. So this was it for has next and next methods within this iterator. So this iterator concept is important. You just go through it once. If you have any kind of doubt, you can let me know. Okay, it's not that difficult to understand. Yeah, initially you may feel a little bit clumsy to understand like how it is working, but once you know the flow, it will be easy for you to understand. Okay, but in interviews, mostly they will focus upon put method, get method, and contains method, contains key method. So focus upon that first. If you are clear with that and if you have time, then you try to understand this. This is also important because you have to use it in your project. So internal implementation, you should know like how it is being worked internally. Yeah, so I hope you got a clarity on this, like how it is being worked. And this is a resizing, which I already told you how data is get resized. So old bucket size multiplied by 2 once it crosses threshold. Okay, so this was it for HashMap, and HashSet is internally calling these methods only. If you see put method, which is present in the existing map, custom HashMap put method, then contains key remove. These are all our created methods. It is not present within the Java's methods, map methods. Okay, so yeah, this was it. I have covered everything starting from set, internal implementation of set, internal methods, how map is being called from set, then map interface, why it is kept differently, internal implementation of map, and all custom implementation of important methods present in map. So these all things I have covered in this one particular video. If you like this video, please like, share, and subscribe. And do let me know in the comment box if you want to create me videos on a separate or specific topics which are most commonly asked in your interviews and you are not able to answer it more confidently. So I will be very much happy to help you with that kind of questions as well. So till then, I will be signing off. See you in the next video. Till then, it's Devjit Roy. Bye bye. Hi everybody. I provide consultation calls or one-on-one session calls or one-on-one mock interview sessions for all of you so that you can ace ahead in your IT interviews, okay, and crack the big service based or big product based organization. So how can you do that? So I am taking mock interview sessions, so you can go ahead in the description box below and you can book a call with me, okay, one-on-one session call, and we'll be having a one-on-one conversation.